This is advanced math, Unit 3, Lesson 5. Unit 3, Lesson 5 for advanced math notes. All right, today we're going to be filling in the unit circle. This is something we've done before. It is review. It should feel like review. So think of how your Math 3 teacher taught it to you, because it may be different, it may be the same. I'm just going to quickly go through and fill the pieces in that we know for sure first. This is 0 degrees. This is 90 degrees. This is 180 degrees. This is 270 degrees, which is over here is 360 degrees. So remember, 0 and 360 are coterminal. They are the same thing. 270. All right. These are called quadrantals because they're on the x and y axis. This is 1, 0, 0, 1, negative 1, 0, and 0, negative 1. All right. Next one I'm going to fill in are my 30 degrees. This is 30 degrees, also known as pi over 6. Again, we've talked about that in class. I'm not going to draw this in every quadrant, but I just want to show you this is review from our last lesson. Remember, we talked about the long side and the short side. The long side is root 3 over 2, and the short side is 1/2. So the x is root 3 over 2, and the short side, the y, is 1/2. All right, over here, I'm just going to stick with this one. I'm going to fill it all in for all of my unit circle. Okay, quadrant 2. 180 take away 30 is 150. 180 plus 30 is 210. And remember, we never use the 90 and 270, so 360 take away 30 is 330. All right, in radians, the way, there's different ways. Some of you have been taught to count all the way around. The quickest way I think of it is, I know that with the denominator of 6, that this is 6 over 6, and this is 12 over 6. 6 over 6 is 1, or 1 pi. 12 over 6 is 2, also known as 2 pi. So I'm going to go ahead and put that in here. This is 0, and that is 2 pi. All right, so 6 over 6, backtracking or subtracting pi over 6, this would be 5 pi over 6. 180 take away 30 is 150. Well, 30 is also pi over 6, so 6 over 6 take away pi, or 1/6 is 5 pi over 6. 6 over 6 plus 1/6 would be 7 pi over 6. 5 over 6, 6 over 6, 7 over 6. Over here, this is 12 over 6. Backtrack, 1/6 would be 11 pi over 6. So again, depending on how your teachers taught you to fill this in last year, you may have a different strategy. I'm just going to quickly fill in, because this root 3 over 2, 1/2 is going to repeat itself over and over. Long side, short side, negative root 3 over 2, positive 1/2, long side, short side, negative root 3 over 2, and negative 1/2, and then long side, short side would be root 3 over 2 and negative 1/2. All right, next one I'm going to do, before doing the 45, I'm going to do the 60, only because 60 and 30 are a lot alike. So here's the 60. Again, I'm only drawing the triangle in quadrant 1. I'm not going to redraw it in every quadrant. Okay, short side, long side. Short side is 1/2, long side is √3 over 2. 180 take away 60 degrees is 120. 180 plus 60 degrees is 240. And 360 take away 60 degrees is 300. Okay, so that's for all of these blue ones here. So for all the blues, the reference angle is 60 degrees. For all the magenta ones, the reference angle is 30 degrees. 30 degrees here, 30 degrees there, 30 degrees there, and 30 degrees there. Now we're dealing with 60 degrees, 60 degrees, 60 degrees, and 60 degrees. Whew. Okay, so with the 60 degrees, our radians is going to be pi over 3. So I just think of this as 3 pi over 3, and this is 6 pi. 3 over 3 is 1, 6 over 3 is 2, and then I just backtrack 1/3, add 1/3, and then again backtrack 1/3. Okay, so 3/3 take away 1/3 is 2/3. So this is 2 pi over 3. 3/3 plus 1/3 would be 4/3, so this is 4 pi over 3. And this is 6 over 3. 6 over 3 take away 1 over 3 would be 5 pi over 3. And it just repeats itself over and over. Short side, long side. So -1/2 positive √3 over 2. Look at this triangle here. Short side, long side would be -1/2 and √3 over 2. And again, another short side, long side would be 1/2 -√3 over 2. All right, and the last one we have is our 45 degrees. Okay. Now, I really like 45 degrees because it's the easiest of all of them to work with, because it's same and same. The legs of a 45 degrees, 45, 45, 90 triangle, they're congruent. So it's 1 over √2, 1 over √2. Your teachers may have wrote it √2 over 2. If they did, you're more than welcome to continue writing it that way. In class, I will leave it as 1 over √2. All right, this is 45 degrees, also known as pi over 4. And 180 take away 45 is 135. 180 plus 45 is 225. And 360 take away 45 is 315. And just a quick shortcut for the 45s, you can see the 45, 35, 25, 15. The tens place is decreasing by tens, 45, 35, 25, 15. And in the hundreds place, it's increasing by 100. No hundreds place, 100, 200, 300. Okay, let's fill these in. And again, 45s are beautiful because it's 1 over √2, 1 over √2. There's really no thinking about short side, long side. You just have to keep track of your negatives. -1 over √2, positive 1 over √2. -1 over √2, -1 over √2. Positive 1 over √2, -1 over √2. All right, and there is your unit circle. Quickly, I'm going to fill these in here. What's positive in quadrant 1? Just a quick reminder that you did learn this last year as far as cosine is your x and sine is your y. Do you see that? These are unit circles, so the radius is 1. So if you were to do cosine of 30, cosine's adjacent, which is the root 3 over 2. So this is your cosine and this is your sine. And tangent is sine over cosine. All right. So, sorry guys. Okay, so you can see in quadrant 1 that all are positive and none are negative. Cosine's positive, sine is positive, cosine sine, cosine sine, and tangent is sine over cosine, and positive over positive is going to stay positive. Okay, the negatives are right here in the x values. That's all the cosine. So cosine is negative. The y values are all positive. That's your sine. So sine is positive. And tangent's going to be y over x. A positive divided by a negative is going to be negative. So tangent is also negative. Okay, in this quadrant, they're both negative, sine and cosine. So if sine and cosine are both negative, what is positive? Tangent, because a negative divided by a negative is a positive. All right, here, what's negative? All the y values, that is your sine. Tangent's also going to be negative because, again, a negative divided by a positive is negative. And the only thing positive are the x values, which is your cosine. So if you remember from last year, your all students take calculus. All students take calculus is used to remind you that in quadrant 1, they are all positive. In quadrant 2, only sine is positive. That's what the S stands for. In quadrant 3, the only thing positive is tangent. That's what the T stands for. And in the 4th quadrant, the only thing positive is cosine. That's what the C stands for. All are positive. Only sine is positive. Only tangent is positive. And only cosine is positive. All right, so how are you going to use this on worksheet 5? Worksheet 5 is going to give you a bunch of, let me show you. Now, I'm going to do it on the back side of this. If you want to do it in a separate piece of paper so that you can use this to side by side do the work, and then you have your unit circle here, that is up to you. All right, so examples. I'm going to ask you stuff like this. Number 1, sine of 3 pi over 4. All right, reference angle. Now, the biggest suggestion I can give to you is memorize your first quadrant, your quadrant 1. And if you can remember quadrant 1 and apply your all students take calculus, you're good. So many kids on the test, when we give them unit circles, they'll just do this quadrant right here. And as long as they know these values and all students take calculus, and they know their reference angles, 3, 6, and 4, they're good. All right, so here's what I would do. Reference angle is 45 because it's a denominator of 4. 45 is nice. They're both 1 over root 2. The only thing I have to keep track of is which quadrant I'm in. This is 4 over 4, which means 3 over 4 is in quadrant 2. All students take calculus. Sine is positive, so positive 1 over root 2. All right, what if I gave you something like this? Cosine of, let's say, 5 pi over 4. Okay, Again, my reference angle is 45 degrees because the denominator is 4. Sine and cosine of 45 are both 1 over root 2. Let's think of our quadrants. This is 4 over 4, so 5 over 4 is here. All students take calculus. In the third quadrant, only tangent is positive, which means this is negative. If you don't like doing it this way, you can use your unit circle. The only thing is it's going to slow you down if you're depending on this every single time. Like if you do cosine of 5 pi over 4, and then you're looking for 5 pi over 4, and cosine is x, so it's negative 1 over root 2. You can do that. Sine of 3 pi over 4, sine is y, so you're looking here and it's 1 over root 2. Again, same answer. Okay, in order to do the next one, I am going to go over a shortcut you learned last year. Actually, not yet. I'll give it to you in the next one. 3. Tangent of 4 pi over 3. Okay, so what's my reference angle? 60 degrees. This one we're not going to use the shortcut just yet. I'll show you the shortcut later. Reference angle is 60 degrees. Let's just use our unit circle on this one. 4 pi over 3, and then I'll show you the shortcut in just a little bit. Okay, 4 pi over 3 is here. And tangent is sine over cosine. You did learn that last year. Did I write it down anywhere here? I did not. Tangent is sine over cosine, or y over x. Okay, I'll show you what this y over x means. All right, so the value I asked you to find was tangent of 4 pi over 3. Okay, so here's 4 pi over 3. Tangent's going to be sine over cosine, or y over x is what I was saying. So negative root 3 over 2 divided by negative 1/2. Negative root 3 over 2 divided by negative 1/2 equals, the negatives cancel, root 3 over 2 times 2 over 1. I multiply by the reciprocal, crosses out, and it equals root 3. Okay, so easiest thing to do when you're dealing with tangent and y over x, know that every single time your denominators are always going to reduce. So it's easier if you just look here and you know that these are going to reduce, just say root 3 over 1. Negative 1 over negative 1. Negative 1 over negative root 3. On any one of them up here, tangent's going to be 1 divided by negative root 3. Here, 1 divided by negative 1. Here, root 3 divided by negative 1. Why? Because when you put your 2's in there and flip it and reduce it, the 2's are going to reduce every single time. Same thing here with the root 2's. When you divide these and you multiply by the reciprocal, the denominators are always going to cancel out. So 1 over negative 1. 1 over 1. 1 over root 3. All right. Number 4. Cosine of 7 pi over 6. Okay, so here, yes, use your unit circle. There's nothing wrong with that, but I definitely want to give you a shortcut on your hand trick that you learned last year. Now you may think like, oh, that takes too long. It takes a little while in the beginning just to make sense of it. But I promise you in the end, if you get the hang of it, it will speed things up for you, especially on a test. So let me show you how the hand trick works. All right, so 1, 2, 3, 4, 5 fingers. This represents the 0. This up here represents 90 degrees. 0 degrees, 90 degrees. Okay, this is our 30 degrees, 45 degrees, and 60 degrees. What's nice is you really only need to use the hand trick for these two, because 0 is always going to be 1, 0, and 90 is always going to be 0, 1. And 45 is always going to be 1 over root 2, comma 1 over root 2. There's really nothing hard with those three. It's these two that students struggle with the most. So I'm going to show you how to use the hand trick. First off, I know it's always over 2. If you want to look at your unit circle, you can check it. 1 over root 2 or root 3 over 2. All right. Now, I just want to make sure it's either going to be root 3 over 2 or technically root 1 over 2, but root 1 is equal to 1, so I'm just going to call it 1. Okay, and here's how the hand trick works. If they ask you for 30 degrees, you put your hand out, you put this finger down. This is your x value, this is your y value. Again, if they ask you for 30, you put your finger down. This is your x value, this is your y value. There's 3 fingers here, so that's the root 3 over 2. There's 1 finger down here in the y value, so that's the root 1 over 2, which is just 1/2. All right, let's try this finger. Put this one down. You put your 60 degree down. And this is your x value. These down here are the y values. I only have 1 finger up here, so that's 1 over 2, or root 1 over 2. I have 3 fingers down here for the y value, so that's root 3 over 2. And then if you look at your unit circle, that is exactly how it worked out. Let's check. There's our 1, 0, root 3 over 2 for 30, 1 over root 2, 1 over root 2 for 45, 1/2, and root 3 over 2 for the 60. Again, this hand trick is not crucial. You have to know it, but in the long run, it is going to speed things up for you. That, or just memorizing your facts. What sine of 30, what's cosine 30, what's sine of 60, what's tangent of 45, and just have your facts memorized. You don't want to depend on this all the way through because it is going to slow you down in the long run. Okay, so continuing. So let's see if we can use our hand trick here. First off, 6 over 6 is here, 7 pi over 6 is quadrant 1, 2, 3. All students take calculus. Cosine is going to be negative, so we know it's going to be a negative value. Reference angle is 30. This is my 30-degree angle here. So when I put this finger down, they are asking me for cosine, and this is the cosine, this is the sine, so it's going to be root 3 over 2. Not 1/2, because that's the sine. Root 3 over 2. And it's negative because of the quadrant it is in. Now again, you may be thinking right now, oh, that takes too long. The more you do it, the faster you become, and it's going to go quicker than referring to this every single time, because you're going to have to fill this in every single time in order to use it. All right. But you can quickly check. Cosine of 7 pi over 6 is here. Cosine is negative root 3 over 2. All right, number 5. Cosecant 11 pi over 6. Reference angle again is 30. So I'm putting this finger down here. Cosecant's the reciprocal of sine. cosine, sine. So this is 1/2, and the reciprocal of 1/2 is 2. Don't forget to keep track of positive or negative. This is 12 over 6, so 11 over 6 would be here. Cosecant's the reciprocal of sine. All students take calculus. It is going to be negative. Negative because cosine's the only thing positive here, and cosecant is not the reciprocal of cosine. All right, let's just do a few more. Cotangent of 4 pi over 3. Cotangent's the reciprocal of tangent. Really quick, 4 pi over 3, if this is 3 over 3, 4 pi over 3 is here. Tangent is positive, that means cotangent's going to be positive. Reference angle is 60 because my denominator is 3. Here's the 60. Tangent is y over x. So cotangent's going to be x over y. So it's going to be 1 over root 3. Again, if you don't like the hand trick, you could just use your unit circle. It just, in the end, you want to work on memorizing it. Number 7, secant of 7 pi over 4. I like denominators of 4 because they're easier. 8 over 4. 8 pi over 4 is 2. 7 pi over 4 is here. The only thing positive here is cosine. Secant is the reciprocal of cosine, so we're good. It's going to come out to be a positive answer. Cosine of 7 pi over 4, or cosine of 45 degrees, is 1 over root 2. The reciprocal of that will be root 2, and it's positive because it's in the 4th quadrant. All right, that is it for this lesson.